Move on to data structures, and this is by far one of the most important concepts that you will ever learn in your programming career. So, when you're going into a technical coding interview, you're going to have to face several interview questions, and these range from very simple questions that cover your basic knowledge of programming all the way until data structures and analyzing algorithms and time complexities and so on and so forth. And so data structures plays a huge role when it comes to your actual technical coding interview question. So what exactly is it? I've mentioned this in the past before, but I never really explained what it is. All it is it's a way of storing or organizing data so that a task can be performed efficiently. And we use something called Big O notation. It's a certain notation that we use to describe the speed that it takes to complete a program. And it does this by counting the number of elementary operations it takes to complete some sort of task. So when we're describing these, we use certain notations. And here I have a list of the best all the way to the worst. And basically, this is in fast to slowest order. So here we have O of 1, which is a linear search. And it progresses and it goes all the way up until O of n factorial. And if we graph these three, so O of n squared, O of 2 to the power of n, and O of n factorial, we can see that it's an exponential graph. It spikes up very, very quickly. Whereas these, if we were to graph these three values, it'll literally just be a horizontal line for a linear search, and O of log n just slightly curves to the right, and then it becomes fairly linear after one point. These are ways that we can describe time complexity. So you'll hear me use a lot of these different terms, and just know that it literally just means the time it takes to complete a program. So why exactly is this important? So this is important because when we have larger companies, say for example Uber, Amazon, or Google, they use servers, and every single minute that they're using the server, they can be spending up to millions of dollars. And that's because their client base is absolutely huge. They have millions upon millions of users, and so they must somehow be able to keep up with all these users. And that is why time complexity and the time it takes for a program to run is very, very crucial. Because when you run a program, you don't want it to take several seconds. You want it to happen almost instantaneously if possible. And if it takes a long time to process or to complete, then that itself is very, very expensive. So we have to keep this in mind. So our goal is to write time-efficient programs and not just regular programs that just merely work. And you will learn the differences between several of these data structures. So we will be covering the differences between an array and an array list, an array and a linked list, and so on and so forth. There are several data structures, and we're going to be covering every single one of them. And basically, I first cover the theoretical portion of the data structure. And so once you fully understand that, going forward and basically implementing it will be a lot easier. So once you understand the core concepts of a data structure, it's going to be a lot easier to actually implement it into Java. So we're going to move on to linked list in the next video. This was just a quick introduction to what a data structure is, and then slowly as the tutorials go on, we're going to be covering algorithms as well. So we're going to have sorting algorithms, so like bubble sort, and then we're going to go into trees and see how we can traverse through a tree, and so on and so forth. So I really hope you stick around and pay attention very closely to these tutorials, because if you can master these, I guarantee you your interviews will no longer be a nightmare. It's going to be a lot easier to tackle. Thank you so much for watching, and I hope to see you in the next video where we will cover linked lists.